So, finding the mean and finding the variance or standard deviation is an important part of statistics, and we've talked about that over the last couple of lessons. But there are a couple of interesting things that happen with means that we're going to talk about today, and also about standard deviations and kind of how they behave when you start to affect data. Now today, we're going to be using our TI Inspire to do most of the heavy lifting for us in terms of calculating these numbers. So remember, in your TI Inspire, I have some instructions up here in the corner. You're going to start a new document, and you're going to put a list and spreadsheet, and you're going to put all the data in a list. So the list that we're going to make, it says, suppose we have a small company with only 14 employees. So this is my small company, 14 employees. We're talking about a population here. This is everybody. Population. Their monthly salaries are listed below. So I'm going to call this my variable. I'm going to call it X. X is the monthly salary, just so I have a symbol to use in my calculator here. So I have 3,500, 1,200, 900, etc. So my first question is, what is the mean and the standard deviation? Now remember, once you've got this entered into your spreadsheet, into a list, and you've got it labeled, what you're going to do is you're going to press menu and then statistics, stat calculations, and the one variable statistics. One variable statistics gives us lots of things like mean and standard deviation, 5-number summary, all kinds of great stuff. So it gives us all kinds of calculations based on that data. Okay, so if you want to stop the video, pause, and put those numbers in, go ahead and do that. Now I have already put my numbers in. So here are those values, and I've entered in all of our 14 employees and put their numbers in. There they are. Oh, and it says I have 13. So have I missed one? Oh dear, I better check. All right, 35, 12, 9, 1,400, 2,100, 1,800, 1,000, 1,300. Oh, that's supposed to be 700. That would have been a doozy, wouldn't it? And then 1,700, 23, 1,200, 1,400, and 1,100 there. All right. Oh, goodness, I'm glad I caught that. So I have all my data entered into this spreadsheet. And from here, I'm going to go ahead and press menu and statistics and stat calculations. And the one we want again is one variable statistics. We're going to click on through this number of lists. That's just going to say okay. And it says, what's my X1 list? I'm going to use the drop down menu. I labeled that column as X, although you could have labeled it anything. You could have labeled it like salary or anything like that. So I just made it X to make it nice and simple here. I don't have a frequency list. We talked about that in last class as well, but I don't have any categories, etc. I'm good to go. So I'm gonna click OK. And here is my data. So I'm going to go up here to the top. So X bar 1,542.86, and X, the sum of X here, I've got that. I've got the sum of X squared, and you see there's this e to the 7th, so that means that's a big number. So that's 4.008 times 10 to the 7th power. Okay, so very big number there. And then I've got my standard deviation, and since this is a population, then I want to look at the population standard deviation. So when you are dealing with the one variable statistics, remember one of these numbers is always garbage and the other one is great. So since we entered population data, then we're going to read the sigma x number and we're going to completely ignore the one with the s. If we had entered sample data, then we would have used this 720 here as our standard deviation and would have completely ignored the other one. Okay, all right, so I'll pop back to my document then, and it says, what is the mean and standard deviation? All right, and so again, this is a mu, because it's a population mean, so I've got my mu, and I'm just going to, for the sake of brevity in these notes, I'm just going to round to the nearest dollar. So 154, excuse me, 3. Okay, so 1543, that is my mean to the nearest dollar. And then my standard deviation, again, I'm using sigma because this was a population. To the nearest dollar here was 695. There we go, $695. Now, let's say that we wanted to give everybody a $500 a month raise, $500 a month raise. So what do we think that would do to the average? What do we think that would do to the standard deviation? Okay, so to do that, we would take each of these numbers and we would add 500 to them. So for example, 3,500 would become 4,000, and 1,200 would become 1,700, 900 becomes 1,400, etc. So we increase all these numbers. So we could do this exactly the same as we did before. We could take our data, add 500 to each of the numbers, rerun the one variable statistics. But since we got the calculator out, let's have a little fun. So I'm going to actually show you something about the calculator. I'm going to add a new page here, just so it doesn't get confusing. I'm going to add a new list and spreadsheet. And I'm going to go up here, and I had labeled my other variable x. If I type that x in there, I get all those numbers back. And then I'm going to come over here, and I'm just going to type in raise. So this column is going to be the raise. We're going to increase everybody's scores by $500. So in this spot, which we haven't used yet so far in class, this little equal sign is an equation. So I'm going to, I've got this listed as raise. I'm going to press, while I'm in that cell, I'm going to press the equal sign. And so what it does is it's going to say raise equals, and then what I want to say is I want to say x plus 500. So I could literally type in the x, that would work. I can also go over to this button that says var, okay? And if I click on that var, there's a whole bunch of business in here right now because we calculated some stuff, but down here at the bottom is that x. So that's another way to access this information. But I'm going to try to do this the easy way. So let me escape out of that real quick. And I'm just going to take the letter x that matches my title of my variable x, and I'm going to say plus 500. Okay. Now, when you go to do this, a lot of times you're going to get an error, and it's going to say, do you mean the column or the variable? Okay, and so it's asking like, do you mean column X or do you mean variable X? So I'm going to click in here, I'm going to say variable reference. Okay, and it's going to fill that whole column up with all these numbers plus $500, which is very convenient. And now I'm going to go ahead and run the one variable statistics again. And I don't like to be in the cell that I'm in, so I'm going to go over here. I'm going to press menu, statistics, stat calculations, one variable statistic. I have one list, just click right on through that. And now for my X1 list, I'm going to pick the raise. What would the mean and standard deviation be after a raise? Okay. All right, so here is my mean, $2,042, so the mean has gone up. And then here is my standard deviation, which is 695 again. So let's go back to our notes and write those in. All right, so the new mean here, this is $2,043. And the standard deviation is still $695. All right, so what's happened is when we took every single number in our data set and we increased it by 500, if you think about these being on a number line, we increased them by 500, so they all shift over 500. And so the mean, which is the center of the data, also shifts over 500. But the whole set of data moves, and standard deviation is a measure of spread, and so the spread is not changing. The data looks exactly the same as it did before. It just was over here, and now it's shifted over 500 spaces. Every number is just 500 bigger than it was before. So our new mean is basically the old mean, mu, plus 500. And our new standard deviation, well, that's actually still the same. So adding $500 to each of these values actually didn't do anything on this. It just, this stayed the same, just shifted over. All right, so what if we take the same set of data and we cut everyone's pay by $500 a month? What's that going to do? All right, so if I cut everyone's pay by $500 a month, so that means my $3,500 becomes $3,000, etc. My so all these numbers here, they just go down by 500 instead. So again, I'm going to go back to my calculator and let it do the heavy lifting here. And just to keep this kind of clean, I'm going to add a new page again. I'm going to, oh, maybe not. I'm going to go Control and Doc. I'm going to add a new page just to keep it clean. Here's my list and spreadsheet. And again, just so that you can see the difference, I'm going to go ahead and type X in there. There's my variable linked from that first spreadsheet. And then we'll call this, I don't know, like DEC. This is like a decrease. This is what happens when we decrease everyone's salary. So right here in this little box, I'm going to press the equals key, and it's going to grab that variable. Okay, so equals over here next to the trig button. I press equals. It's going to say DEC equals what? And I'm going to say it's X minus 500. X minus 500. And when I hit enter, it's going to say, did you mean the column X or the variable X? So I definitely mean the variable. So that is 3,700, 400. So each of these numbers has just been decreased. And I'm going to run my one variable statistics, menu, statistics, stat calculations, one variable statistics, one list, and this time I want the mean and standard deviation of this decreased value. All right, now my mean is about 1,043, and my standard deviation, because again this is population, is still 695. All right, so my new mean is 1,043, and my standard deviation is 695. So hopefully what you've noticed here is that when we increased all the values by 500, the mean went up by 500 and the standard deviation went up by 500. When we decreased by 500, the mean went down by 500 and the standard deviation still stayed the same. And again, the reason why this is when we take all of our data values and we increase the mean in each of these, it shifts the data, but it doesn't change the overall spread of the data. It just moves it. Okay, all the numbers are still in the same relationship as they were before. And so we have, don't have anything that's changing spread-wise. All right, so let's say we take everyone's salary and this time let's double it. All right, now let's make a prediction about what's going to happen here. So let's say I have my data and I make it double. So if I double all the numbers, like if I had the numbers 1, 2, and 3, they would become 2, 4, and 6. Okay, so it feels like it's going to probably get wider. And if the middle, if I had like 1, 2, and 3, the middle would be 2. If I double it, that middle would be 4. Okay, so the numbers are twice as big. Maybe the mean is going to double. Okay, maybe the standard deviation will double as well. Let's see. All right, so I'm going to go back to my calculator. I'm going to have it do the heavy lifting. Okay, just to keep this clean, I'm going to add a new page. List and spreadsheet. Okay, I'm going to go up here. I'm going to put that X in. Okay, and then let's call this, I don't know, DUB. So we're going to double it. Okay, all right, so I'm going to go in here. I'm going to press the equals key. And it's going to say, what is this? And I'm going to say 2 times X. 2 times X. And it's going to say, do you mean column X or variable X? I mean variable X. And it's going to double all of those numbers. There they are, twice as big as they were before. And now I'm going to run those one variable statistics. Menu, statistics, stat calculations, one variable statistics, one list. And this time I want, see I've got all these variables from before. I want to pick double. My X value is now 3086. My X bar, my mean. If I go down to my population standard deviation, it has in fact changed. Now we're looking at about 1389. All right, so my new mean when I doubled everyone's salary is now 3,086, and my standard deviation is 1,442. Okay, I believe. Let me double check that number, because is that right? Yep. Nope, not 1389. Looks like I have a mistake. 1389. Let me fix that. I either have a mistake on my key or a mistake in my calculation. In fact, let's just double check. I'm going to go to my calculator here. Okay, have all my numbers in there. That looks pretty good. I'm going to go to Scratchpad really quick here. What would happen if we took 695 and doubled it? Yeah, 13.9. All right, so I'm going to go back to my document. I'm going to go home. I'm going to go current. I'm just going to double check 1389. Let me fix that on my notes here. 1389. Oh, I was erasing. Thank you all for your patience. 1389. So if you notice what's happening here, when we doubled all of our data values, our new mean also doubled. So we have 2 times what that original mean was. And our new standard deviation also doubled. It's 2 times what that original standard deviation number was. Okay, so if you think about it again, if my numbers were like 1, 2, and 3, and I double them, the 1 becomes 2, the 2 becomes 4, and the 3 becomes 6. So the data value not only kind of shifts over where it is, but it becomes twice as wide as well. Okay, and so that also contributes to that, not only increasing the range, but it's also increasing that spread. So when I just added everything to one number, to all the numbers, it didn't really change it. It just scooched it one way or the other, but it didn't change that spread. So what would happen, and this we wouldn't do this with real salaries, but what happened if we multiplied by negative 0.5? Okay, so that's like cutting it in half, but I'm multiplying it by a negative number. We wouldn't do this with salaries because you wouldn't like make someone pay you to work for them. All right, so that means my 3,500 becomes negative 1,750 and my 1,200 becomes negative 600. So if you think about it, if you've got a bunch of negative numbers now instead of positives, you would anticipate that your mean would probably become negative as well. But what's going to happen to that spread? Is it going to be, or sorry, that standard deviation, is this going to become negative too? Okay, so I'm going to take my calculator here and I'm going to add a new page. Oh, I did it again. Here we go. Control, new page, list and spreadsheet. Okay, and I'm going to say here X, there's my data, and we'll call this one half. Okay, so half, and I'm going to say, what does this, let's say this equals, and I'm going to use the negative key, which is, there it is, negative 0.5 times x. Negative 0.5 times x. Okay, and I'm talking about variable x. Okay, so again, there's all those negative numbers. I'm going to run those one variable statistics. Statistics, stat calculations, one variable statistics, one list, and this time I'm going to take the one that says half. Okay, so you notice that my mean is half as big as it was before, and it is negative. But when I go down and look, I went too far. When I go down and look at my standard deviation numbers, both of the standard deviation calculations for sample and population are both positive, but they are half as big as they were before. Okay, both positive, half as big as they were before. And also, if you were to think about interquartile range, if I took Q3 minus Q1, negative 550 minus a negative 900, that's also going to end up positive. All right, so I'm going to go back to my paper here. All right, so what's happening with the salary? This one is 771. Okay, and this one, oh, sorry, negative 771. And this one was a positive 347. Okay, 347. All right, so what's happened here? The new mean is definitely negative 0.5 times the old mean. It's half as big and it's negative. But the standard deviation is just like regular 0.5 of the old standard deviation. It didn't actually change to negative. So another way to think about that is even though we multiplied by a negative, it only had kind of like an absolute value effect. The negative sign didn't apply. All right, and the reason why is because if you think about your data values, let's say you have the numbers 1, 2, and 3, and you multiply them by negative 1, they're all going to kind of flip over the axis of the number line. But the spread is not going to become negative because spread is a discussion of distance, an average distance, and so that negative is not going to apply. All right, so here are a couple of rules that come out of this then. All right, so rules about means. The first thing is what happens to the mean and standard deviation when you add or subtract a constant to each data value. Okay, so if you're going to take each data value, you're going to add or you're going to subtract some constant value to it. So what we notice happens is that the mean itself, okay, if I add to all of my numbers, the new mean is actually just that much bigger. It also increases by that same constant. And if you subtract from each of the variables, that new mean is just that much less than all of those other numbers. Okay, so when you add or subtract to a data set, all those numbers, they sort of scooch up or scooch down the number line. And that changes where the center is. So the center changes the same amount. The standard deviation, though, if you add or subtract to the data set, it does not change the spread at all. All it's changing is the location or the position of the values. So if you are adding or subtracting to your data set, that new standard deviation, that is going to be the same as the old. It's unchanged. It doesn't do anything to it. Now, if you multiply each data value by some constant, okay, the mean also multiplies itself by that constant. So if you double all of your numbers, your mean will double. If you triple all your numbers, your mean will triple. If you multiply all your numbers by -1/17, your mean will get multiplied by -1/17. Whatever happens to the data also happens to the mean. Standard deviation, though, is supposed to be this measure of center, okay? Or sorry, this measure of spread. And since it's a measure of spread, it does increase, or if you increase or decrease those numbers, it does, but the negative doesn't really affect it because we're always talking about those squared deviations from the mean. And so the negative doesn't really apply to us anymore. So what happens is your standard deviation does change, but it changes by a factor of the absolute value of C instead of just that regular one, okay? So knowing how these numbers change can save you a lot of time. Like if I know that I want to, on average, my workers are making $1,300 and I want to double everyone's salary, I need to know that that means the average is going to make it $2,600. So it saves me some time being able to work with those rules. Okay, now the second set of rule that you may have is what to do when you are combining data sets. Okay, so I have two spinners and we're going to play a game. And the game says you have to move the same number of spaces as the sum of the two spinners. So like the first spinner, I've got 1, 2, 3, or 4. So for example, if I roll a 1 over here and I roll a 2, or sorry, spin a 2 over here, then I would go 3 spaces. Okay, so I can spin a 1, 2, 3, or 4, and a 1, 2, and 3. Now I'm going to go to my TI Inspire here, and I am going to make a new document. So it's going to say new document. Do you want to save the old one? Nope. Goodbye, document. Okay, and we want another list and spreadsheet. And just to keep these straight, I'm going to call this A for spinner A, and I'm going to call this B for spinner B. So remember in statistics, you always want to put those labels on the top of your variable. And then, I just dropped my pen, it rolled off the table. And then I'm going to enter my values. So for data set A, I had 1, 2, 3, and 4. And for spinner B, I had 1, 2, and 3. All right. So here we go. I am going to run the one variable statistics for each of these values. So I'm going to go menu, statistics, stat calculations, one variable statistics. There's one list, and it's going to say, what is that list? I'm going to say A. All right, so list A, this is going to give me my mean and standard deviation. And yes, I know I could do this by hand, but we're just trying to do this very quickly in our calculator. So I have a mean of 2.5 for this set A. And since this is a population of values, this isn't a subset of possibilities, this is all of them. I want that sigma, okay, which is 1.12. All right, I'm going to, before I forget these two numbers, come over to my notes and add that in. So the mean, oh goodness, is 2.5 and the standard deviation is 1.12. And something that we do sometimes when we have two different data sets, we might call this the mean of A, and we might call this the standard deviation of A. So we use like a little subscript to help us differentiate between those two values. So the mean of A equals 2.5, the standard deviation of A is 1.12. All right, I'm going to go back to my calculator and I'm going to run this next value. So I'm going to go over one more column. I'm going to do B, menu, statistics, stat calculations. Got carried away there. Statistics, stat calculations, one variable statistics. I've got one list. This time I'm going to pick data set B, and it says, okay, the mean is 2 and the standard deviation is 0.82 here. So I'm going to go over to my data. Here we go. The mean of B is 2, and the standard deviation of B is 0.82. All right, so there's my mean and my standard deviation for each of these two data sets. Now, let's say I want to talk about just overall how you play the game. I'm supposed to spin the one spinner and spin the second spinner and add those together, and that's how many moves. So what are the different possibilities for the two spinners? Now, I've already wrote these in. Okay, So I have, I could have a 1 and a 1, a 1 and a 2, a 1 and a 3, etc. So if I look at that, there's 4 ways to spin the first spinner and 3 ways to spin the second spinner. That gives me 4 times 3. There's 12 different possibilities of combinations of the spinners. So 1 and 1 give me 2, 1 and 2 give me 3, 1 and 3 give me 4, etc. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so those are my 12 different possible sums. Okay, now I want to find the mean and standard deviation of these. So again, I could go to my calculator. Now unfortunately, I'm not going to be able to do like A plus B to do this in my calculator. I am going to have to input these by hand, because if I try to do A plus B, what's going to happen is it's going to say, well, you only had 4 numbers in A and you have 3 numbers in B. They're not the right numbers. This isn't like I'm adding the first and the first and the second and the second. I want all the different combinations. So I'm just going to call this S for the sum of the 2, and I'm going to enter them. So 2, 3, 4, 3, 4, 5, 4, 5, 6, and 5, 6, 7. There are my 7 values, and I'm going to run the one variable statistics. Menu, statistics, stat calculations, one variable statistics, one list, and I want set S. Okay, and we'll scroll back up to the top. Okay, I am looking for my mean. My mean is saying 4.5, and my standard deviation is saying 1.38. All right, so my mean is 4.5, but my standard deviation is 1.38. Now I want to go back and look at this. So I noticed that my mean of A was 2.5 and my mean of B is 2. So I feel like what I really feel like I'm seeing here is just like before, the means appear to be behaving. When I did A plus B, every A plus every B, the mean of A plus B looks like it's the same as the mean of A plus the mean of B. Or in other words, 4.5 looks like it's the same as 2.5 plus 2. Okay, so I'm getting the same value, 2.5 plus 2. All right, but the standard deviations are not working. 1.12 and 0.82, those add up to 1.94, and that is definitely not 1.38. So we're going to have to come back to that. Those standard deviations, those aren't working. Okay, so if I add them, if I add all the A's to all the B's, the means add. So the means are behaving, but the standard deviations are not behaving. All right, so sorry about the film cut. So here, let's find the differences. So what if I'm going to subtract the value from B instead? So in other words, I take A minus B. So if I roll a 4 the first time, I get to go forward 4 spaces, but then I have to go back 2 spaces. So I have a net 2. So if you have a negative number, that means you would go backwards. So when I'm talking about all the different combinations, if I do A minus B, I have 0, -1, -2. In other words, what happens if you take every possible A minus every possible B? And I've already got these typed into my calculator on a new page. So I've typed in all 12 possible differences here, and I just called them D for difference. And I'm going to find that mean and that standard deviation. Menu, statistics, stat calculations, one variable statistics, and we're going to find the mean of those differences. All right. Oh, I just went to a different page. Okay. It's angry at me. So X bar there is 0.5, and I'm going to look down at my standard deviation. It is also 1.38. Okay, that's really interesting. So my mean now, what I'm seeing is the mean is 0.5, and my standard deviation is still 1.38. So remember, we had 2.5 and 2. So again, the mean appears to be just behaving just like a beautiful, obedient statistics child here. The mean of A minus B, of all the A's minus all the B's, okay, it acts like the mean of A minus the mean of B, or in other words, it acts like 2.5 minus 2. That seems to be working just fine, okay? But the standard deviation, that is not working, and it doesn't really make any sense because 1.12 minus 0.18 is a very small little number. It's definitely not 1.38. So this got bigger, and it's the same as it was. So like it doesn't make any difference if I'm adding and subtracting, I'm getting the same value. So what is going on here? Okay, so here's what's actually happening. So when we're talking about sums and differences, they behave very much like what happens when you have multipliers and you have adders to your data. Okay, whatever you do to the data, also the mean behaves in the same way. The means behave. They kind of like do what they're told. They're very obedient statistics. Okay, so if you take every value of x plus every value of y, your mean is going to, the mean of x and the mean of y is going to be your new mean. You're going to add them together. So the means are going to combine just like you would expect they would do. Okay, same thing with subtraction. Okay, if you subtract, if you have the mean of a and the mean of b, and you talk about all of your a minus b's, then you're going to have the mean of a minus the mean of b. These behave. So if you take all of your data values and you find all possible values of x minus y, or x plus y, the mean of the new data behaves exactly like you think it is. The standard deviations, however, don't work. I mean, we can obviously see that they do not combine well. It doesn't matter if we're adding or subtracting. That is not equal to the addition or subtraction of either of those. That doesn't work. The means do not add. The standard deviations do not add. The standard deviations are not combining in any way. And if it doesn't work with real numbers, then it doesn't work with the variables. So that's important. What's actually happening is this. Basically, I'm just going to take a little side story here. If we think about like a 30, 60, 90 triangle, or like a Pythagorean triple here, how about 3, 4, 5? Okay, so I know based on the Pythagorean theorem, and it's true, that 3 squared plus 4 squared equals 5 squared. In other words, 9 plus 16 equals 25. That is definitely true. What is not true, however, is that 3 plus 4 equals 5. That is a big old false. So when we're thinking about the way that standard deviations behave, I want you to think about standard deviation as a measure of distance. It's a distance value. So instead of 3 plus 4 equals 5, it's really the standard deviation of the first one squared plus the standard deviation of the second one squared equals the standard deviation of the combined set squared. All right, so variances are always going to add, because it doesn't matter if I draw my triangle this direction or that direction. It's still 3 squared plus 4 squared equals 5 squared. Because we're talking about those x minus x bar squareds, the subtraction value doesn't come into play. So this variances are always going to add. They're always going to add. So what you're going to do is you're going to think like it's a Pythagorean triple. You're going to add the variance, and variance is just standard deviation squared. You're going to add those individual pieces squared, and then you will square root to find your actual answer. So let's go back up and test to see if that works. All right, so again, our original standard deviations were 1.12 and 0.82. All right, so I'm going to take a different color here. Maybe, okay? And I'm going to take 1.12, and I'm going to square it. That's going to give me the variance of A. And 0.82, I'm going to square it. That's going to give me the variance of B. And when I put that into my calculator, okay, and let me just pull up this and go ahead and do that. Maybe. Okay, so I'm just going to go to a scratch pad here. So 1.12 squared, okay, plus 0.82 squared. Okay, I end up with this number 1.92, etc. That's my squared value. I'm going to take the square root of that answer now. And looky there, there's that 1.38. Now it's 1.39 because we're doing some rounding here, which has caused some issues. Okay, so to get the standard deviation, I'm going to square it, but that's going to give me the variance of the A plus B. Okay, in order to get the standard deviation, I will square root that answer. So if I take the square root of the answer that I got for variance, I end up with that 1.38 number. That is my standard deviation. Okay. And so the cool thing is this works for differences too. So it's the same number, it's the same calculation. So even though I'm subtracting my data values, they always add, they always combine. All right, so let's do a couple of examples of using this. All right, so the food court next to the mathematics building at your university offers several varieties of sandwich. On the billboard outside, they advertise the mean and standard deviations for sandwiches to try to lure in hungry math professors. The mean calories for the sandwich is 350 calories. There's our mean, with a standard deviation of 75 calories. There's our standard deviation. What happens to the mean and standard deviation if they add a 40-calorie dollop of mayo to each sandwich? Okay, so if you think about the your sandwiches being sort of an X here, they're going to add a 40-calorie dollop. That means that we're going to have an X plus 40. So our data set is going to be 40 calories more, everything. We're just going to take everything. So if I think about all my numbers, if I increase them all by 40 calories, whoop, the mean is going to change. It's going to change predictably. It's going to move, but that standard deviation is going to stay the same. Okay, it's going to shift it, but it's not going to stretch it or compress it in any way. All right, so the mean of X plus 40 is going to be the original mean, 350, plus those 40 extra calories. There's my 390 calorie mean. My standard deviation of X plus 40, again, remember, it just scooches over. It's 40 up. Not going to change that spread. That's going to stay the same. So that's going to stay 75. That extra 40 calories is not going to change that that value. All right, so 75 calories. All right, what happens to the mean and standard deviation if they remove a 150-calorie slice of cheese from each sandwich? Well, first off, it's going to be like a whole lot less sales because who wants a sandwich without cheese? That's just awful sad. So again, I'm going to take my values X, all those numbers, and I'm going to subtract 50. All right, subtract 50. So what is that going to do to my mean? So I take all my numbers, I take 50 off, it's going to scooch it over, but it should stay about that. The spread is not going to change in this case. So my mean of X minus 50 should be my original mean, 350, minus those extra 50 calories, giving me 300 calories as our new mean. Standard deviation, however, is not affected by these little addition and subtractions. Those are just little scooches. Okay, so that's going to stay 75. All right. Now, what happens to the mean and standard deviation if they increase the size of their sandwiches by 30%? All right, so it's like you have your original sandwich and then you've got like 30% more sandwich here. All right, so if you think of that in terms of algebra, what we're actually doing is we're multiplying by 1.3. So multiplier. So I'm taking everything and I'm increasing it by 30%. So what's going to happen is all my numbers are going to be 130% of what they were before. They're going to be 30% bigger. So the spread is going to change. Okay. But the mean also going to change in that. So those multipliers are going to affect both of these values. So my mean of 1.3x, that's going to be the same as 1.3 times that 350. So the calories are going to increase by 30%. Which is 455 calories. Okay. My standard deviation is also going to increase by 130%. And just as a reminder, if this had been negative, I would have ignored that multiplier because we multiply by the absolute value of that number. So 1.3 times 75, that's going to give me 97.5 calories. So that multiplier affects both of those. Just as a reminder, the means behave, standard deviations don't. All right. Now, they decide to offer a combo meal that includes sandwich and dessert. The dessert menu, all right, so dessert menu has a mean of 180 calories and a standard deviation of 20 calories. All right, so I'm going to put little subscripts here so I can keep these apart. I know that the sandwiches had a mean, the sandwich, of 350 calories. And that the standard deviation of the sandwich was 75 calories. All right, so what is going to happen here? All right, what are the mean and standard deviation of the combo meal? So you get to pick one dessert and one sandwich and put them together. Okay, so remember, it's not just like the first dessert and the first sandwich, but you can like mix and match. So there's lots of different values there. So like if they had 10 sandwiches and 5 desserts, there are 50 different combinations that could happen. All right. So I want to know, what are the mean and standard deviation? So the means are going to behave. If I want to make a combo meal would be a sandwich and a dessert. Those are going to behave. I should be able to take the mean of the sandwiches plus the mean of the desserts and get the new mean of the combo meal, which is 530 calories. All right, now as far as the standard deviation, remember the standard deviations do not behave. They're a distance, so they're going to behave like Pythagorean theorem. If I want to find the standard deviation of the sandwich plus dessert combo meal, instead I'm going to start with variance. Okay, so it's like a squared plus b squared equals c squared. So I'm going to take 20 squared and 75 squared. A squared plus b squared equals c squared. Okay, this thing over here is equal to 6,025. So the variance is this. All right, so to get this to the standard deviation, okay, if I want the standard deviation now, I am going to square root that value and get my standard deviation, which is about in the neighborhood of 78 calories if you round it. Okay, so remember with standard deviations, if you're combining two different data sets, you're going to think about Pythagorean theorem, a squared plus b squared equals c squared. So type a squared plus type b squared gives you the combination squared. Even if this was subtraction, we would still add them. Okay, so variances always combine with addition. All right, so what you need to be able to do, you need to be able to work with these rules of means and variances, and we will talk about this in some future chapters. So this will come back again. This won't be the only time you see it. All these little rules about what to do when you're adding and subtracting different data sets and how they apply by numbers. These are not on your formula sheets. These are things that you do need to know. All right, so you're going to practice with some of these, and it's okay to have questions because this is a brand new idea, a brand new concept. If you're going to remember anything, remember that means behave, and they basically do what they're told. If you add, they add. If you subtract, they subtract. If you multiply, they multiply. They behave, okay? But standard deviations are a little squirrely, okay? So if you're adding or subtracting by a constant, those just shift. It doesn't change your spread. Multipliers are going to affect it though. And then when it comes to combining two data sets, because they are distances, they're going to combine like distances. So think Pythagorean theorem, a squared plus b squared equals c squared. Square of the standard deviation plus square of the standard deviation equals square of the standard deviation. It's going to take a square root to solve that problem. All right. Have a great day.